Hi everyone, this is Geometry, lesson 7-5, proportions and triangles. In this lesson, we'll be able to find the lengths of segments using proportional relationships and triangles resulting from parallel lines. Do you remember our parallel and perpendicular lines from topic 2? We're going to use that in triangle similarity as well. So let's see how parallel lines could be useful in this lesson. So let's look at explore and reason. Draw a triangle like the one shown, and then you divide one side into 4 congruent segments and drawing lines parallel to one of the other sides. So you're gonna divide these sides, this side on the left to 4 congruent segments by drawing parallel lines that's parallel to the base side on the bottom. So part A, how many similar triangles are in the figure? So you can see there's one triangle here and then another triangle here, another triangle here, another triangle here. Are they all similar? Well, they look like it, right? It should be because they're gonna be proportional because this side is equally divided into 4 parts. That means they're proportional. And as long as they're all parallel, like the lines are parallel to the other side over here, it's gonna be proportional. So including the original triangle, there are 4 similar triangles. Their sides are proportional. Okay, how are the lengths of the parallel segments related to each other? What about the parallel segments? Are they proportional as well? Well, the shortest segment is half the second shortest, and then 1/3 the second longest, and then 1/4 the longest. Yeah? Because they're parallel and they're equally divided. Shortest segment is half the second shortest, 1/3 the second longest, and 1/4 the longest. Okay, so when parallel lines intersect 2 transversals, what are the relationships among the lengths of the segments formed? Would be the question that we'll keep asking. Okay, so let's look at example 1. Explore proportions from parallel lines. So we're gonna try to understand the concept here. Look at triangle JLN. LN is 9.6. LN is 9.6. What are LM and MN? If we know LK is 3 and KJ is 5, and these are parallel lines. Are the sides divided proportionally? Explain. Determine how triangle JLN and KLM are related. So since these are parallel lines, we know the angles, the corresponding angles are congruent, right? So these are congruent. Yeah? Because if we treat LJ and LN as transversals, then they're gonna be corresponding angles. All right, and then opposite, what is it? Oh, right, never mind. And then we know the triangles are similar by the AA theorem. So they're going to be proportional. All the sides will, corresponding sides will be proportional. So 3 to 8 would be proportional to LM to LN, right? Which is 9.6. So LJ is going to be 8 if you add these. And so 3 from this triangle, small triangle, over 8 should be proportional to LM over 9.6. And then you figure out LM by solving the equation. LM is going to be 3.6. So LM, now that we know LM is 3.6, you subtract it from 9.6 and MN is 6. Okay. So now we got LM and MN. And we know that since these triangles are similar, all the sides are going to be proportional. All right, so let's look at try number 1. BD bisects AC and CE. Is AE parallel to BD? Okay, see if you can check if they have the parallel lines. So you need to use the properties. Okay, if they're similar, they must be also parallel, right? See if the triangles are similar and check if they're parallel. Come back when you're ready for answers. Okay, are you ready? What is the easiest way to prove this or to explain? Okay, so let's notice our lengths here. It bisects both sides, right? So CB is 5, AB is 5, AC is 10, CE is 12, CD is 6, DE is 6. Okay, so if we look at these two triangles, CBD and CAE, okay, this is 5, that's 6, and we have this angle. And then this is 10, that's 12, and we have this angle. Okay, are the sides proportional? 5 times 2 is 10, 6 times 2 is 12. So yes, the sides, both sides are proportional, and we have the same congruent angle, which is C. C is gonna be congruent to itself, right, by reflective property. And so are the triangles similar? Yes, by SAS, similarity theorem, we can say these two triangles are similar. And then we can say, because the angles are congruent, so since the triangles are similar, that means all the angles must be congruent, like all the corresponding angles must be congruent. And since corresponding angles are congruent on the parallel lines, we can see that these are parallel lines. Okay, so let's summarize what we just talked about and write it down. So yes, triangle CAE is similar to triangle CBD because of SAS similarity theorem. Thus, angle CAE is congruent to angle CBD. So lines AE and BD are parallel by the corresponding angles theorem. Okay. So let's look at these theorems. Theorem 7.5 is side splitter theorem. If line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. Okay. 7-6, triangle mid-segment theorem says if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half as long. Okay, side splitter theorem and triangle mid-segment theorem. Let's look at example 2. Use the side splitter theorem. So, can you figure out the value of x in triangle PQR using the side splitter theorem? Since ST is parallel to PR, we know they're going to be proportional. PS over SQ is proportional to RT over TQ. So then write the information that we know and solve for x, and you can figure it out. Okay, let's see if you can try number 2, part A and B for Y and Z. Can you figure out Y and Z here, the length of the parallel lines? Okay, so have you figured out A and B? What's the value of Y? You're going to use the information x is equal to 6. We just figured out that x is equal to 6. That means SP over here is 6 plus 2. So that's 8. Okay. And x here is going to be 6. So 6 plus 3 is 9. VR is 9. And UP is 12. So you know that UV also bisects QP and QR, right? So by the triangle mid-segment theorem, Y triangle mid-segment theorem, Y is equal to 1/2 PR. Okay, PR is 30, so 1/2 30 is equal to 15. So Y is 15. Okay, let's write down the explanation. UV bisects PQ and RQ. So by triangle mid-segment theorem, Y is equal to Y is half the length of PR. Okay, that was part A. What about part B? What about Z? How do we know? How do we figure out Z? Because we know these triangles are similar, right? QST and QPR, because they're parallel. These sides are parallel. They're going to be proportional. So let's use the proportions to figure out Z. So ST over RP should equal to QS over QP, since triangles QST and QPR are similar. So that means Z over 30 is equal to 16 over 24. Solving for that, let's go down here. Multiply 30 on both sides, you get Z is equal to 16 over 24 times 30. Simplify is 20. Wait. 4, 6 is 24. 4 is 16. Okay. And then you simplify these. So 10 times 2 is 20. Okay. Explain your reasoning. So what did we say? Triangles QST and QPR are similar. By the side splitter theorem. So ST over RP is equal to QS over QP. There. Okay, so let's look at the next page. Corollary to the side splitter theorem is if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So if we have three parallel lines like this, and they all go through two transversals, then the segments that cut by the parallel lines are proportional. So AB and DE. AB is proportional to BC. AB and then AB, they're proportional. Okay. Look at example 3. Find a length. This is the application problem. A reflecting pool is separated by walkways parallel to Lincoln Street and Jefferson Street, which are parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X feet represent? We want to find X feet over here. Just as we looked at the corollary to the side splitter theorem, we're going to use that and say, oh, we have all these parallel lines and it splits two transversals over here. That means all the segments are proportional. Okay. So Walnut Street over here and Spruce Street over here transversals of Jefferson and Lincoln Street, the walkways that separate the pool, they're all parallel. So the segments are proportional. Let's write an equation. So in order to find X, you want to use this segment 24, and you can use the one next to you, 60 and 72. So X over 60 must be equal to 24 over 72. Okay. That's the corollary to the side splitter theorem. And solve for X, X is 20. So the amount of tiling represented by X is 20 feet. Okay. Can you try this? Try it number 3. In example 3, how much tiling does Y feet represent? Can you figure out Y using the same theorem? Come back when you're ready for answers. Okay, so in the same way, you're gonna write the similar proportion. So using 60 feet and 72 feet, you can write a proportion 24 over 60 is equal to Y over 72. Okay, and you're gonna solve for Y, multiply 72 on both sides, and then you get Y is equal to 72 times 24 divided by 60. You can simplify before you actually divide them out by yourself. Okay, I'm dividing it by 2s and 3s. And then 72 times 2 is 144 divided by 5. Which is in decimal 28.8. Okay, so Y represents 28.8 is your solution. All right, we got 2 more examples. Let's look at the next page. Example 4, investigate proportionality with an angle bisector. In triangle KLM, line N, segment NL bisects angle KLM. Okay. Compare the ratios Kn over Mn and KL over ML. Is triangle LKN similar to triangle LMN? Explain. So we can compute the ratios of the corresponding sides for the given measures using Kn over Mn. So these are corresponding sides, right? 10.5 over 7.5 should be equal to 14 over 10, the corresponding sides. And they're both 1.4, right? So the ratios are equal. But the third pair, NL and NL, the ratio is 1 because it's by itself, right? So you can't just compare two and say, oh, they're proportional, so they must be similar. But the shapes are slightly different, if you noticed. And the corresponding side NL is basically equal to itself. So NL over NL is 1. That is not the same as 1.4. So if you don't have all sides that are proportional, the triangles are not similar by definition. So the two triangles are not similar. So check all three sides. So try number 4. Draw ML. Draw ray ML and a line through K parallel to NL. Okay, these are parallel. Let P be the point of intersection. Okay, that's the P. Part A is triangle MNL similar to triangle MKP. Explain. First, you notice that the angle M must be the same. We just need to see if the sides that include angle M are proportional. So in this case, if we know the angles, included angle is equal, then we can just check the proportionality of two sides that makes the angle. And then we can use the SAS similarity theorem. But if not, if we don't have that, we have to check all sides, SSS, to use SSS theorem. Okay, but this one, example 4, did not work. But here, you can check if they're proportional. We don't know LP, so how can we reason this out? Use the information of the parallel lines. If you have two parallel lines and MP is a transversal, what do you know about the corresponding angles? This angle and that angle is the same, right? Okay, so these two angles are the same, but do we really need that? Yes, we do. By AA similarity theorem, right? So if the small triangle M and L, your M is equal to this M over here, and L is equal to P. So by AA similarity theorem, they're similar. The triangles are similar. Okay, let's write that down. Triangles MNL and MKP are similar by the AA similarity theorem. M is congruent to itself, and because lines NL and KP are parallel, corresponding angles MLN and MPK are congruent. Okay. What about part B? So this one's part A. Let me move this up so that I have room to write B later. Okay, is angle LKP congruent to LPK? Are these congruent? How can you tell? Well, use the information from part A. You already know that these two triangles are similar, right? And so that means all sides are proportional. So 7.5 over 10.5 plus 7.5 is 18. Over 18 should be equal to 10 over MP. And so MP is equal to 10 times 18 over 7.5. So what's MP? MP is 880 divided by 7.5. That's 24. MP is 24. So if you subtract 10, LP is 14, right? So since these two sides are equal, this is an equilateral triangle, and you can see that the base angles by definition will be congruent. Okay. If you have another way to explain, that's great. Explain your own explanation, but this is one way to explain it. So yes, we can say since triangles M and L and MKP are similar, the sides, the corresponding sides must be proportional. Solving for MP by the proportion 7.5 over 18 is equal to 10 over MP. MP is equal to 24. So LP is 24 minus 10, which is equal to 14. Since LP and LK are congruent, triangle KLP is an isosceles by definition. The base angles must be congruent. So the angles LKP and LPK are congruent. That's part B. Okay. So let's look at theorem number 7-7, triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into two segments such that the ratio between the segments is the same as the ratio between the sides adjacent to each segment. So if a ray is an angle bisector in a triangle, then the opposite sides that are divided are going to be proportional. Okay, to with the triangles that are made. Okay, so UX over WX is proportional to UV over WV. All right, the last example. Use the triangle angle bisector theorem. So using that theorem, we can figure out the missing informations, AD and DC. Okay, so use the proportion to figure them out. See if you can try it number 5. Okay. Okay, there. So use the triangle angle bisector theorem to try number 5, A and B. Remember in example 5, we know that this is DB is a bisector. So by using the triangle angle bisector theorem, this over this is equal to this over that. So you can see X and 13 minus X. They're gonna be, these triangles are gonna be proportional. So X over 10, x over 13 minus x is equal to 10 over 16. Okay, so same thing for here. That's HK is the angle bisector here. That means GK over KJ is equal to GH over JH, or 12 over 3x minus 7 is equal to 3x plus 18 over 3x plus 3. If you started from triangle HKJ, it needs to align. So whatever is in your numerator, it must be from the same triangle. Okay, so try number 8. 12 over 3x minus 7 is equal to 18 over 3x plus 3 using the triangle angle bisector theorem. And then you cross multiply to get it. 18 times 3x minus 7 is equal to 12 times 3x plus 3. And then you use the distributive property to multiply that out. 54x minus 126 is equal to 36x plus 36. Okay, and then you add the like terms. 54 minus 36x is 18x. Then 126 plus 36 is 162. So divide 162 by 18, x is equal to 9. So there's your value of x. X is equal to 9. What part B? What are the values of GH and GK, your expressions here? Now that you know x, simply substitute your values in. 3 times 9 plus 3 is going to be GH. So GH is 27 plus 3, that's 30. And GK is 3 times 9 minus 7. That's 27 minus 7, which is 20. There you go. Okay, so your strategy to solve these type of problem is to apply the triangle angle bisector theorem to set up a proportion that can be solved for x or whatever variable you have, and then substitute it into the expressions for the lengths of the sides. Okay, let's summarize our lesson. Proportions in triangles. We looked at 3 theorems. Theorem 7-5, 6, and 7. They all have names. So the side splitter theorem is when you have 2 parallel sides. And you can say that the segments that are splitted from the parallel sides are going to be proportional. Okay, and triangle mid-segment theorem is when you have the mid-segment, so it divides 2 sides into equal parts. It bisects it. Then we know the mid-segment must be parallel, and it's gonna be 1/2 of the base side that's parallel to. Okay, and then triangle angle bisector theorem is when you have a bisector, angle bisector, what are your vertices? The triangle that's made from the bisector are going to be proportional. So the sides that are not the bisector are going to be proportional. All right, so that was lesson 5, the last lesson of topic 7, proportions in triangles. So topic 7 was all about similarity. And if you have any more questions about topic 7 or this lesson, feel free to ask Ms. Kang in class. Otherwise, we'll continue with topic 8, right triangles and trigonometry in the next video. Bye, guys.